Let's talk about making compressors in Alibre CAD. So I'd done a compressor video in SolidWorks and FreeCAD, and I think I even did one in Fusion 360 and Onshape. But I haven't done one in Alibre, and I had someone reach out and ask me how to do it. And that's a very fair question, because I think when it comes down to plain definitions, the methods I used in the other platforms don't apply here. But as you can see, you can make some great compressors and whatnot in Alibre, so I don't think it'll stop you. So let's talk about what making a compressor looks like in Alibre, what that workflow looks like. I'm going to go through two methods, and some methods that Alibre can do you couldn't do in, say, FreeCAD, and vice versa, because they're just different platforms that operate differently. So I think Alibre has some really useful tools in being able to make pretty unique shapes due to its capability. Let's create a new part. All right, so we're in the new part environment in Alibre. This is Atom, or the hobby license version. And we're going to create a new sketch, but first let's go to View. I'll toggle my sketches on, toggle my references on, and I do like my view cubes. So with our view set, we'll go to Activated 2D Sketch. I'm going to go right on the XY plane, and let's create two arcs. I'm going to make them off of the same center point so that they're concentric with one another. I'll create a third arc that goes to these arc ends here, and then I'll make a line. Make sure that this line is horizontal, and then we'll give this dimension 0.75, and then we'll give this 0.0625 as sort of a thickness. I'll select the horizontal constraint and move from here to there to the center point, right? So now that the arc is tangent to vertical at this very top point there, give this another dimension. And we're going to go with, say, 0.25. I'll give this outer arc a dimension here. Let's go with 4. And you can do this in millimeters or inches. It doesn't really matter. If you're a design engineer, you should be able to use multiple units. And I'm in inches right now, I think. Let's go with giving this a radius of 4. Okay. So we're going to deactivate that sketch. Let's jump onto this plane, right? That'll be our YZ plane, and we'll create a sketch. All right, we're going to give this an overall height of 2.5, 0.0625. From the origin, we'll give that 0.25. And we'll give this a height of, say, 3. Okay, so we'll deactivate the sketch. So the simple way, the first method that I like to do a blade with is a loft from here to here. Now, so I'm going to check off the minimize twist option, and that saves us from making a guide curve to go with this, right? So we also could say minimize curvature, and I've had it at certain lofts where that actually works as well. But either turn off minimize twist or minimize curvature, one of them should work. You can always simplify the surface if you wish, and it's fun to try little combinations to see what you get. But anyway, let's specify a tangent to give this a little bit of a curve, and we can say 0.5 and 0.5. Oh, I have to check this box. Yep, 0.5, right? And that gives us kind of a reasonable looking blade. Now you may say, well, that method doesn't give me very much control of the blade, and I would agree. But if you're looking to make a simple, compressor type shape, I think that'll work. So let's just finish off the real basic profile here. and then we'll get into making a more controlled type of shape. So we'll go here. I'll add in another line coming down. Right, and that is to handle the thickness of our blade here. Let's go with a dimension of 0.5, 0.0625, 4. I'll grab an equal relation from here to there. So we've just dimensioned the thickness of like the floor of our compressor. We'll go to an arc. And let's establish a vertical from this point to the very end here. That way we know that the floor of the compressor is tangent and horizontal at that point. Looks like I may need to add a horizontal on this line. Oh, no, it's already just a little visual illusion there. It was already horizontal. Let's go with, how about 2.55, so it goes just above our blade. Deactivate, and then we'll do a revolve. We'll select our center axis, of course. All right, circular pattern. Right, this stuff is just so quick and easy. Let's say blade profile of 13. We're going to go evenly spaced, and again we'll choose our center at the same axis. There it is. I'll add a few details just to make it feel somewhat complete. We'll add some fillets on the inside and outside edges. That makes it a little bit busier up here, right? If you're at Boeing or something, you may want to consider a multi-radius fillet or something, but I think you probably just use only surfacing for something that complex anyways, but here I think we're doing just fine. So we'll add in a hole down the middle and some fillets. So one thing that I think is pretty awesome that Alibre does is fillets. It really is a strength for something that is of this price point. It's just incredible. We're going to say fillet, and of course 0.5 is too big, so if we go down to 0.1, right, and I select a few of these. You can start to see that as I add these fillets, it really gets pretty busy in this area. So if I apply this and we take a good look, you can see that, you know, flow gets pretty interrupted. This is a pretty busy area right here. Probably not ideal, but it's also really nice to have fillets here. So let's delete this, right? And this is, I love this capability that Alibre has. And remember, I am in Atom. This is not the Pro license. You'd think that this would be a Pro feature, but they've really made a lot of great features available to the hobby. Let's go to variable radius. Let's go here. And let's say 0.001 is what we want at the start. There we go. Okay, so we have 0.1 and 0.001, so we start with the smallest radius ever, and the more that we progress down, the bigger that this radius gets. 0.25, right? We can go big. Oops, I accidentally selected that. So, I mean, we go something like 0.25 on here. I mean, look how big we can go, and it doesn't interrupt the flow up front. So a variable radius, and I should just do a video on this so that people specifically can search up how to do a variable radius, but this is This is really powerful stuff. I'm going to go back down to 0.1 and start adding variable radii. Now if I do a variable radius on this end, you can see we get an error, probably because it's trying to put the big end of the radius over on the other side, right? So we're going to move the selected item. I'll just select these edges and let you know when I'm done. Alright, so I have my multi-radius fillets that seem to be working really well. I did a few separately to avoid capping sequence errors, and I can continue with my fillets if I wish, but I think that's good enough for a compressor here. So, you know, you'd put a hole in there or whatnot. So I'm going to save that. And then I'm going to do a save as and choose method 2. All right, so how do we have a more controlled method when we go to make this compressor blade? So I'm deleting these things out of my tree, and I don't need the loft or the sketches either, right? I'm just taking it back down to the revolution so I don't have to remake that at all. All right, so here is my revolution. That's all I've kept from my tree. Let's go to the XZ plane, activate a sketch, and I'll reset my view. There we go. So sketching on my XZ plane, let's take a look at what we've got. I want to make a blade profile where we loft from the other direction. So let's make an arc here. I'll constrain it here with maybe a dimension of something like 0.8125. We'll give this a tangent arc. We'll give the end arc a total height of 2.5. We'll make it vertical, center point to this end point. Give this a radius of 0.25. We'll give this a radius of, say, 6. We'll take this endpoint and make it horizontal there with the midpoint. And then we'll simply close up a profile. All right, so I'm sketching the profile of blade that I want to have at the very center of the compressor. And we'll say horizontal, 0.0625. Tangent. We'll make the line vertical. So we're fully constrained there. We're going to deactivate a sketch. Next, let's make a path that we wish for the blade to travel. Sketching again on the XY plane. You know what? Let's deactivate the sketch. I want to just have a better visual, so I'm going to suppress my revolution. There I can see my sketch a bit better. So we'll again go on the XY plane, activate our sketch. We'll project this line here, maintain association as a reference figure, and that way I can have a nice intersection with my curve. So I'll reset my view. Again, we'll grab coincident. I can take that line and make the center line of that arc coincident so we know that we're tangent to vertical at the endpoint. We'll give this something like a radius of 4.6. Now from the origin, I'm going to put a vertical dimension of 3.5, and that isn't just some arbitrary dimension. That's very intentional, as we'll talk about later. And then we'll do another arc. We'll go tangent here to here. And we'll have this land on horizontal. You don't necessarily have to have this here, but it is nice to not have to define a plane that's normal to this if we're going to loft along this and use it as a guide curve, or have a plane that is horizontal at this endpoint that isn't normal to the plane. So I've added just a little bit here to help my loft profile. You don't have to, but I like having a loft profile like this on a blade where constant thickness might be a little bit more critical. This might help to achieve that, depending on all of your settings. Okay, let's just give this a known length away. Let's say 6 inches, right? So we're fully defined. I'm going to deactivate sketch. We'll select this plane and bring it out 6 inches, right? The dimension that we just gave it. We'll activate a sketch on the plane that we just made. I'll reset my view. That way it makes a little bit of sense. All right, so sketching now. Let's project this line, maintain association as a reference. Nice little intersection point right there that we can sketch off of. We'll create an arc. We're going to make sure that this point is horizontal at that start point for the same reasons that we've done all the other ones. We'll give this a dimension of 6. We'll add another arc. Looks like they are tangent. That's exactly what we want. We'll give this a dimension. So they give this a radius of 2. And I'm going to make this vertical with its midpoint, right? So then we ask, how tall do we want this? I'm going to say as tall as the other one. You can say 2.5. Likewise, you can import elements from this other sketch with maintained association if you want to try to go for some design intent there. Then we add some arcs off of our endpoints here and close out our profile. So there we have a compressor blade. We're going to go vertical and horizontal over here. There we are. And I think we're one dimension away. 0625. Oh, I guess we have a tangent that we have to add as well. There we are, fully defined. So we'll deactivate the sketch. I will unsuppress my revolution. I can grab sketch 4 in the tree here. We're going to say loft. Over to here, we can choose a guide curve. Right, now we've got more of a controlled profile of blade. Now you may say, I need more control. So we'll go through that. Just as soon as I prove this out here, we're going to do a circular profile, center here. Give this 13 and we'll make sure that it's evenly spaced. All right. So you can see we just trim off the ends of the blades to make that compressor. But what if you want even more control? Well, I use that 3.5 dimension that we sketched out earlier intentionally, right? That would be sketch 5. I selected 3.5 with a lot of intention. And you can also, if you need to add even more detail, break these arcs up and add little sub-arcs that would make up one arc, and use those endpoints the way that we're about to use that midpoint at 3.5 right now. What I'll do is select my ZX plane, create another plane that is 3.5 away. Of course, it went in the wrong direction, so we'll edit and reverse the direction. Let me delete my loft. And of course, to delete my loft, I'll also delete my pattern. So right where we have that inflection point between the two arcs, we have a plane on that point, and we can use that to our advantage. First thing I'll do is create a sketch on the plane that I just created, reset my view to the other side, and I can highlight that inflection point by saying project a sketch, choose the arc whose endpoint is right where that plane is, if you can see that. We're going to create a reference figure with maintained association. And now I can create an intermediate sketch. And again, I'll reset my view here. So this is the point that I care about, right? Not this far point that is connected to nothing, but this inner point here. So grab an arc. Make sure that we are horizontal here. Grab a tangent arc. Tangent arc will say I have a 1.5 radius, make this an overall height of 2.5. We'll take a vertical to this arc center point with its endpoint, so it ends on horizontal. So I have some leeway in how I want this to be. Give this a vertical dimension of how about 1.5? Close off our blade profile. We'll make sure that we're tangent. And then we simply add a vertical and a horizontal. So we've deactivated the sketch. Let's see what an intermediate profile looks like, right? We loft. I didn't mean to add sketch 5 though. Loft from sketch 4 to sketch 7 to this next sketch. Then we add in a guide curve. There we have even more control because we control the center point just like that. Next, what if we want even more control? What if we have to control the top profile? And how about a case where we might have to, right? Let's say that we run a circular pattern on our loft, 13 instances evenly spaced around this center. And we say OK. When we look from the top, what if we want our blade to have a straight profile for a certain distance? Well, it can be really hard to do that with just adding cross sections like I have here. So how do we do that? Well, luckily, there's a way. Let's delete our pattern. Let's delete the loft. Let's go to our sketch plane. We've made our blades a consistent height, right? So 2.5 inches. That plane should be at the very top of our blade profiles. So let's activate a sketch. In fact, let's deactivate our sketch. I want to see my sketch better, so let's suppress the revolution. That's an easy way to view our sketches. Right? We'll activate a 2D sketch. Now we'll project a sketch. Let's do that vertical line with maintained association as a reference. And I can continue with each of these. We'll say OK. Now I've got little reference points that I know intersect the sketches that I've used. So we'll go with a tangent arc and another tangent arc. And I can give this top profile whatever I want it to be. We can go ahead and fully constrain it. Right. Easier if I reset my view. We'll go with horizontal from this point to the arc's endpoint. In fact, that just constrains everything. And now I've got that straight profile that I want. And you can't replicate this in FreeCAD, at least to my knowledge, not yet, with just a simple loft or a simple sweep, because we have multiple guide curves now. But you can see Alibre gives us the power to be able to do this, which is pretty cool. So we'll go loft from here to here to here. We want to add a guide curve there. But now I want to utilize that straight profile, and I can with the guide curve that I just made. And now I know we're coming straight out. And you can add as many intermediate sections as you want to fully control this blade in its profile. Really cool way to loft with Alibre. We're going to unsuppress our revolution. We'll add a circular pattern from here to the center. 13 instances looks excellent, right? And we have a good face there. All right, so let's create a sketch and just create something that will help us profile these blades, right? I'll add a tangent arc here and another tangent arc around here. And we'll go with vertical, vertical. Make that 4. Zero 0.0625. 0.6, 0.125, again, you can make any shape you want to define this. 2.75, so we go well above the blades. Give the center point a coincident constraint. 8. Two. That will work then. We'll just go with that, whatever. 2.199 might as well be 2.2. Okay. Deactivate, revolve cut. That's our center. So there's some compressors and some methods on how to make them. I'll add some details using the dimensioning and filleting techniques that we've used prior to this. Won't make you sit through it again. And that should be the second method that we use to define a compressor in Alibre CAD. So I think Alibre CAD is a fantastic tool for working with this kind of stuff. This is, of any modeling method I've ever used on this channel, this one in Alibre has the greatest control over the blades, and Alibre is capable of that method. So I hope this was helpful. If it was, please subscribe. I'll see you in the next one.